Everyone, today we're going to learn about the electrolytic cell. Tying to the learning objective from College Board that the student can make predictions about the reactions using half-cell reaction and potential and Faraday's law, and the student can analyze data regarding electrolytic cell to identify properties of the underlying redox reactions. In an electrolytic cell, the reaction is not spontaneous. We have to use electrical energy to produce chemical change. And this is forcing the current through the cell, and therefore the cell potential is negative. Such as electrolysis of water. This is the overall reaction. Water is electrolyzed into 2 moles of hydrogen and oxygen, as in the diagram. Now, in the reduction happening at the cathode, the 4 moles of water is reduced into 2 moles of hydrogen gas, forming 4 moles of hydroxide ion. And then the cell potential is negative 0.83 volts. In the anode compartment where the oxidation takes place, water is oxidized into oxygen, producing 4 moles of hydrogen ion, generating 4 moles of electron. The oxidation potential is negative 1.23 volts. When the two reactions are added up together, we have negative 2.06 volts. Another would be electrolysis of molten, pure NaCl sodium chloride. The sodium ions are reduced at the cathode and deposited as sodium liquid in this reaction. So here is the electrolysis diagram. You can see the sodium ion is attracted to the cathode to form sodium liquid, while the chloride ion is attracted to the anode, and it is oxidized into chlorine gas, and you will see the greenish yellow gas bubble being formed. Overall, it's 2 moles of sodium ion and 2 moles of chloride ion to make 2 moles of sodium liquid and 1 mole of diatomic chlorine gas. So we often use the down cell and produce sodium metal at high temperature. Another electrolysis will be aqueous sodium chloride. Now, this is having water in competition with the sodium ion and chloride ion. At the cathode, sodium is not produced because water is more easily reduced to produce hydrogen gas. Now look at the reduction potential. It is less negative to produce hydrogen at negative 0.83 volt than to produce sodium, which is negative 2.71 volts. Therefore, in this case, hydrogen will be produced instead of sodium. At the anode, now, looking at the two equations, we would have thought that the oxygen would be produced because it requires a smaller negative cell potential, negative 1.23 volts, whereas that of chlorine is negative 1.36 volts. However, that is not the case. There's a term called overvoltage. The actual voltage to drive the water to form oxygen is 1.4 volts, and therefore the chlorine will be preferentially oxidized into chlorine gas. Therefore, the overall in the electrolysis of aqueous sodium chloride is to produce chlorine gas at the anode and hydrogen gas at the cathode. And the electron is still flowing from the anode compartment into the cathode compartment, and the inert electrode, such as platinum, is used as electrodes. Try practice problem number 1. Predict the product of electrolysis of lead iodide aqueous solution. Now at the cathode, there are competitive reductions between the lead to ion and water. Because the reduction of lead to ion requires a smaller negative cell potential, therefore the lead ion will be preferentially reduced. At the anode, again, we have two competitive half reactions, the oxidation of iodide to become iodine and the oxidation of water to become oxygen. Noted that the oxidation potential for the iodine is a smaller negative than that of water, negative 0.54 volts. Therefore, lead will be produced at the cathode and iodine will be produced at the anode. Anytime when we deal with electrolysis of aqueous solution, we always have to consider the competition with water. And we should write down both reactions, the half cell reactions, to compare the cell voltage to make a decision. Another one is electroplating, which is often used to coat a surface with an active metal by removing the metal ion from the anode and plating it out on the cathode. Such as in this diagram, if we have a small spoon and we want to silver plate it, what we do is we have the anode bar made of silver, and the cathode will be suspending the silver spoon. Now, as electron flows through the circuit, the silver ion will then migrate to be coated as silver metal on the outside of the spoon. And we use stoichiometric mole relationship to calculate the amount of metal deposited. First, we take current times time to give coulombs. And then from coulomb, we use dimensional analysis to convert into moles of electron. And again, using mole relationship to convert into moles of metal. And finally, converting into mass of the metal. Now, Q is the coulomb of charge, is equal to current I in ampere times T time in seconds. As we know, the Faraday's constant states that 1 mole of electron contains 96,485 coulomb of charges. And then we look at this mole relationship. To reduce silver ion, we need 1 mole of electron. To reduce 2 moles of magnesium ion, we require 2 moles of electrons. And to reduce 3 moles of aluminum ion, 3 moles of electrons will be required. So look at this mole relationship. Try this practice problem. Calculate the mass of magnesium formed upon passage of a current of 60.0 amp for 15 minutes. And first, we write down the reduction of magnesium ion requiring 2 moles of electron to form magnesium metal. Now, the Q, the charge of the electron is equal to 60 amp times 15 minutes converted into seconds. So that's 54,000 coulomb of charges. Now we use dimensional analysis to convert into moles of electron using Faraday's constant, and then convert it into moles of magnesium, as 1 mole of magnesium is formed from 2 moles of electron. Now multiply that by the molar mass of magnesium, 24.3 gram, we end up with 6.80 gram of magnesium being plated out. Another question will be, find the volume of oxygen produced by the electrolysis of water at a current of 4.00 amp for 10 minutes under STP conditions. First, we write the oxidation reaction for water, which is water becoming oxygen. Then we write the reduction reaction for water, which is water becoming hydrogen, and we multiply that by a coefficient of 2 to equalize the number of electrons. So the overall is 2 moles of water to become 2 moles of hydrogen and 1 mole of oxygen. Now we calculate the coulomb of charges. 4 amp times 10 minutes converted into seconds is 2,400 coulomb of charges. Then we convert it into moles of electron using Faraday's constant, and then convert it into moles of oxygen, and then using 22.4 liter per mole of oxygen. So we end up with 0.139 liter of oxygen. To sum up what we have learned today, we learned the use of external current to force electrons through an electrolytic cell to drive a non-spontaneous redox reaction. Naturally, we would expect the E0 of the cell to be negative. We also learned how to predict products of electrolysis in water, in molten sodium chloride, and in aqueous sodium chloride solution. Finally, we learned how to calculate mass of metal electroplated or volume of gas generated in electrolysis by using stoichiometric relationship. I hope that you have found this video helpful. If you like it, please give us a like. And I look forward to seeing you in the next video.